In this problem, you have to solve for x. And the equation is 4 raised to the power x plus 9 raised to the power x plus 25 raised to the power x. And this is equals to 6 raised to the power x, 10 raised to the power x plus 15 raised to the power x. How will you solve this problem? If you look closely, you can observe that x is an exponent of each term. And similarly, you can also observe that many terms are a square of some number, like 4. This is a square of 2. 9. This is a square of 3. 25. This is a square of 5. And what about these terms? 6, 10 and 15. Basically 6 is 2 into 3. 10 is 2 into 5. And 15 is 3 into 5. So this gives me a hint. It looks like something a square plus b square plus c square. Or in fact 6 can be written as ab and 10 can be written as bc and 15 can be written as ac. So using all this, can you solve this problem? If you are not able to solve, let us see the hint or let us see the solution. So now I can write this 4 as 2 raised to the power 2 and this raised to the power x. 9 as 3 raised to the power 2, this raised to the power x. 25, 5 raised to the power 2 raised to the power x. And this is equals to 2 into 3 raised to the power x plus 2 into 5 raised to the power x plus 3 into 5 raised to the power x. Now I will use rules of power. If you remember, if we have something like this, a raised to the power m raised to the power n, this can be written as a raised to the power m into n. Or this can also be written as a raised to the power n raised to the power n, m. This means the position of m and n got interchanged. Initially n was outside, now this is inside. M was inside, now this is outside. So position of exponent got interchanged in this case. Now the second rule I will use, that is if you have a b raised to the power m, this can be written as a raised to the power m times b raised to the power m. So now with these two rules, let us try to expand the given expression or rewrite. So I can basically interchange the power here. So this becomes 2 raised to the power x and raised to the power 2. Similarly, this becomes 3 raised to the power x raised to the power 2. And this becomes 5 raised to the power x raised to the power 2. And this will be, I can use this formula, that is ab raised to the power m. This is nothing but a raised to the power m multiplied by b raised to the power m plus 2 raised to the power x times 5 raised to the power x plus 3 raised to the power x times 5 raised to the power x. Now see, you have a square plus b square plus c square kind of thing. So let us do some substitution. So the substitution is, let us say 2 raised to the power x is equals to a, 3 raised to the power x is equals to b, and 5 raised to the power x is equals to c. So with this substitution I can rewrite this is a square plus b square plus c square. This is equals to ab. This is this is c. So this is a times c. So this is ac. And this term 3 into 5, that is 3 into 5, that is bc. Now let us take everything to the left hand side. So I will have a square plus b square plus c square minus AB minus BC minus CA is equals to 0. Now this can be arranged in formula, that is A minus B whole square plus B minus C whole square plus C minus A whole square. But to do that, we will need to multiply by 2. So let us multiply by 2 throughout. So you will have 2A square, 2B square, 2C square, 2AB, 2BC and 2CA. Now let us try to rearrange these terms. So you will have A square. So I am writing A square plus A square, B square plus B square, and similarly other term I can write, but 2AB, 2BC I will keep as it is, 2CA, and this is equals to 0. Now let us arrange these terms. So A square is here, B square is here, and 2AB is here. So A square plus B square minus 2AB, this is basically a formula. If you remember, this is A minus B whole square. So this formula, A minus B whole square, this is equals to A square plus B square minus 2AB. So if I use this formula, this becomes A minus B whole square. Similarly, if you see this term, this is B square, C square minus 2BC, this will become B minus C whole square. And the last term that you have here, that is A square plus C square minus 2CA, this will become plus C minus A whole square. Now sum of three terms and a square of these terms is equals to 0. This means this all term has to be 0, because a square should always be greater than equal to 0. This is also greater than equal to 0. This is also greater than equal to 0. This means sum of these terms are 0. This means A minus B whole square is equals to 0. B minus C whole square is equals to 0, as well as C minus A whole square is equals to 0. So if A minus B whole square is equals to 0, this means A is equals to B. B minus C whole square is equals to 0, this means B is equals to C. And C minus A whole square equals to 0, this means C is equals to A. This means now I know that is A is equals to B is equals to C. So this is the condition that I have. Now if you see the value of A, B, C, A is basically this term 2 raised to the power x, B is 3 raised to the power x. So this means now I can say 2 raised to the power x is equals to 3 raised to the power x is equals to 5 raised to the power x. And this is possible only when x is equals to 0, because in that case x 2 raised to the power 0 is 1, 3 raised to the power 0 is 1, and 5 raised to the power 0 is 1. So x is equals to 0 is the only solution for this equation. So this is the solution. So I hope you enjoyed this video, and if you enjoy, please share with your friends, like this video and subscribe to my channel. Thanks for watching this video. I will see you in the next video. Thank you.